Hello everyone and welcome back to Arctic Retro, and today it is building day, and what I'm gonna build today is in front of me here, and it involves of course a lot of soldering. And as you might already know, I love these kits where you can solder in components to a small board like this and make something work with an old computer but with new components. And this is actually the Nunchuk64, and this is an adapter that makes it possible to use the Nintendo Wii nunchucks or controllers on a Commodore 64. And of course maybe other machines as well. It was invented by Tulan. I'll zoom into the board. So it says Nunchuk64 Tulan 2020, and I'll link to his GitHub project. Anyway, this was actually produced by BWAC, and he made the true hole version of this. True hole version by BWAC 2020. And he sent me this to play with, and I'm gonna do it now. This is the GitHub page for DJ Tulan, and here you can see the information about the project and what kinds of controllers are supported, and the layout for the PCB, Gerber files, etc, etc. And yeah, if you go to the supported controllers, there's a README file here which tells you about the different modes and how the different controllers will behave in the different modes. And for the firmware, you can go to the releases, and under here, if you scroll down a little bit, the latest actual release is 1.2.0, and if you open assets, you can download the ready-made hex file, and you don't have to compile it yourself. If you visit the BWAC on YouTube, you can also find a video here about the Nunchuk64 True Hole version.
Hey, welcome back to another video. So in this video, I'm going to talk about the Nunchuk64 Through Hole version. The SMD version was first made by Tulan some years ago.
So the circuit is based on an Atmega 328 microcontroller. I'm not gonna go into detail on how it works or how this circuit works. I haven't studied it really, so I'm just gonna build it and test it. Alrighty, it's time to turn on the soldering station and heat up the soldering iron, and let's get soldering. This should be fairly straightforward. There's only through hole components, except for these 9-pin D-sub connectors. I'm not really sure how they're supposed to be soldered into the PCB, but I'll figure it out. Alright, let's see if we can make this work. Just cleaning my soldering tip, and yeah, I think I'm gonna start with the microcontroller. It's a little bit wide for the holes. That is common. Alright, so it's in. I just use this little gum here just to keep things fixed so they're not moving. Alright, so ready to solder. I'm not gonna use any flux. This is a new board and it is clean, and this solder tin is very good. So So that went smooth. Just the rest to go. Alright, that was the microcontroller. It went smooth. Next up is this switch. SW1. Oops, it has little bent legs. Then we have these 4 transistors, Q1 through 4, and they are all the same type and value, so I'm gonna take those now. Q1, 2, 3, 4. I'm trying to make it look pretty as well as just soldering in things, so yeah, straightening the components and things like that. Even though I'm not a professional, I like to do things nice and with yeah, good quality. Let's call it that. But then again, I sometimes do mistakes because I am, as I said, not a professional in electronics. And sometimes people comment on my video about things I did wrong, and that's okay for me, because then I can learn from them. And also, I am starting to get old, so I'm not the steadiest hand in the world, and not the best eyesight in the world either, so but I can manage. So I'm just soldering some of the pins here, and then I'm gonna turn it around because the others are in the way. If you hear some voice in the background, it is my son. He is downstairs gaming on his computers. Sometimes he shouts out something. I don't know what game he's playing. Alright, that was the transistors. Just a little snipping action, and then we can continue. I also like to touch up on the solder points after I have snipped off the legs, because with the less metal, then the solder is flowing even better and yeah, looking better. Then it's a U1, which is 3.3 volt voltage regulator, and it is a little bit wide-legged for the holes, so yeah, just gonna straighten the legs a little bit. Oops, I think those were bridged together two of the legs. I'm just gonna cut off, then I fix this. Like that. Next is this 10K resistor array, and these have a dot on one side, and yeah, the dot is on this side, and the square hole is square hole. The squared hole is where the dot is going. To keep it straight, I'm just using this gum or blue tack, white tack. Next is this smaller resistor array. RN1 also has a dot on that side, and yeah, a square hole. There's a bit of a glare on the PCB sometimes, sorry about that. I'm trying to adjust the light, but I couldn't get it quite right. I'm trying to not breathe in the smoke. I didn't turn on the fan because it's a bit noisy. The smoke is not good for you, at least this leaded solder tin. But whenever the smoke comes up, I just hold my breath or blow in that direction gently. So, almost there. Two capacitors, 22 microfarads. And these are polarized, so of course the direction matters. It is marked with a small plus, and the long leg is the positive leg. I zoomed in a bit so you can see a real close-up soldering of capacitors, if you like that sort of thing. Next is this LED, light emitting diode, and here BVAC has actually taken really good care of me and explained what the anode and the cathode is. And yeah, the cathode is the shorter leg, and that should go into the square hole. And also to help me remember what the cathode is, K is short or kort in Norwegian. It's rule for remembering. I have never thought about that, so that was excellent. Thanks, BWAC. So here is D1, and the short to the cathode is going to the square hole. So let's make it look nice. Then we have C3 and C5, which is small 100 nanofarad capacitors. These are not polarized, so you can put them in any direction. So it's a Saturday afternoon right now here in the Arctic Retro House, and everyone is doing their own business. Finally, there's two resistors, R9 and R10. These are different values. Alright, so I'm just gonna bend the legs like this. I actually got the comment once that I did bend the legs on the components the wrong way, which could actually damage the component, and I actually agreed. Yeah, it became a little too wide actually, so I'm gonna straighten it again. So now it's narrower. Let's see. I probably should have checked the value to see that it is actually correct, but I'm confident that the BWAC did the correct job with the components. Final component, except for the contacts, resistor R10. Ow, still hot. Then it's time for the connectors, and these are the Nintendo connectors, and BWAC told me that these were hard to get with good quality. There are some Chinese clones or copies, but this should be better, and yeah. Pins are a little bent, that's not a problem. Come on. I finally made them fit. So I'm gonna solder these anchor points first. They're quite large. Yeah. Alright, so you might notice that I bridged the two of the pins. Alright, fixed. So initially I was thinking, how do I solder on these D-sub connectors, and actually it's quite easy. You just push them right onto the PCB. But I might try them in a computer first, just to get the perfect fit. So I tried it on in Commodore just to test if it fits, and well, it was perfect with the pins in the middle of the soldering pads. Try not to shift them while soldering. Just use a little bit first. Not too much heat, because you can easily melt the plastic inside the contact. So be quick. Then the other side. Alright, that's it. Soldering is done, looking nice. Finally I can clean off the PCB with some alcohol, and yeah, I just use a little bit of paper tissue. Time to test. Does it fit? Yeah, perfect. The adapter fits just great in the machine, but there's still one important task to do, and that is to program the Atmega microcontroller. I already soldered in the pin headers, that makes it possible to program the chip via some other programming device. My plan is to use my TL866 programmer, and this is the Plus version. It has an external program port, so I'm gonna use that one, or at least try to use it. I have hooked up the programmer to my computer, and in order to program this, you need to go to the GitHub page and download the source code and compile it into a hex file, which you can use to program the controller. However, that's a bit of a hassle to have to compile the code and everything. So actually you have releases here, and under releases I just browse and scroll down to the first version that has the hex file. This 1.20 has 3 assets, and one of them is the Nunchuk64 hex file. So you can just download that and don't have to compile the source code. I have connected the Nunchuk to the programmer via this breadboard, because I only had these wires available, and I also found this recipe, or how to connect the programmer to an Atmel ICSP connection, which is the one here, and I think this is correct now, hopefully. Alright, so let's see now if we can burn this software to the chip, and I have here the XG Pro software for the programmer. Sorry about filming the screen, but I don't have the capture software on this PC. It is too slow for that. So I just leave the load file options default, the Intel hex format. And I have selected the Atmega 328P DIP28 chip here already, and we are not going to use the CIF socket to program it. We are going to use the ICSP port, and now it tells us to make sure certain things, and the ICSP VCC must be enabled. And if you have the check ID on, then you can make sure that the connection is correct if you can read the chip correctly. So let's try to read it. Alright, it is reading flash, so seems like the connection is good then. Yeah, everything's read correctly. So now it overwrote the file I loaded, so I'm gonna load it again, and yeah, the Nunchuk64 hex. And make sure that the IC config information has these fuse bytes set to hex 62 and D9. And that is actually the configuration of the chip, and maps out to these settings here. Okay, now it's time to try and program the chip. So I have checked verify, and yeah, let's try program, and just leave everything on. Erasing succeeded, programming flash. Verifying flash. Yeah, it succeeded, so it read back the flash content, and it was verified as the same that was written. Okay, everything succeeded. Nice. So just to double check, now I can read the chip again and see if it actually has the content that was written. And it has. Nice. So now it's time to test that if the chip is actually performing the code on the Nunchuk64. So at least the first check is to see that the LED is turned on. It was not before the chip was programmed, so turning on the machine now. So I just push the button and then the LED comes on. I'm gonna insert one of the nunchucks from a Nintendo Wii. I connected this nunchuck for the Nintendo Wii that we have in the house. And I just tested it on the Wii and it is working, so nothing wrong with it, but I can't seem to get it to work with the Nunchuk64 adapter. So I have tried all the different modes and yeah, it simply won't react at all. This one has an accelerometer, that's why I do this. Try to activate it, but no, it doesn't seem to work no matter what kind of mode I'm in. I tried both the ports as well, so I don't know what is the matter with this, but obviously it can't be used with this adapter. Or maybe there's something wrong. I did something wrong with the soldering. I also got this Super Nintendo controller for the SNES Mini, and this has the same plug, so this should work. It should be supported. So let's see, does it work? Yes, it does work. Great. So at least that one works fine. Oops. So there's a little moon patrol. So that means that the circuit is working and I did a good job in soldering it. However, why this doesn't work, I have to investigate a little bit more and maybe ask the author of the code and see what he says. So I tried different things, switching between the ports and yeah, nothing. And also you don't even need to have a game running to test this. You can just put it into control port 1 and yeah, just hit some buttons, and as you can see this one produces output on the screen. Let's try the nunchuck. Nope, nothing. Nada. Alright, I think that was it. I made my goal, which was to solder up and get this adapter for the Nunchuk64 working. However, it didn't work with the Nunchuk, but it did work with the Nintendo gamepad, and I'm pleased with that. Now I can use these on games. Okay, and that's it for this video. I hope you enjoyed the content, and please tell me if you didn't. And I just want to say thanks for watching, and please subscribe to see more. And also I want to say thanks to my Patreons for the support. Thanks, bye bye.